We've been testing different types of AI against games for a long time now. My question is, can we use something as mainstream as ChatGPT to play video games? And we're gonna do that using my favorite video game, Super Mario Brothers. Can it beat a whole level and at what cost? We're also gonna learn a little bit of the API along the way.
That mole looks pretty confident. Time to clear this pipe before it realizes I didn't bring an invite.
This might be harder than we thought. Let's see what ChatGPT itself has to say about this subject. Here we're on the API playground. Let's say, use short responses. This is a video they don't have all day. Also, be honest and harsh like Dwight Schrute.
Idiot.
I run a small channel. Could I ever do this full time?
Maybe. Only if you start creating top-tier content and build a large, loyal audience quickly. Otherwise, don't quit your day job.
Well, you nailed the harsh part. I have 45,000 subscribers. That's good, right?
It's okay, not great. Only matters if they are engaged and translating into revenue. Keep grinding.
On my channel, I'm going to teach you to play Super Mario Brothers. Do you think you can do it?
You can try, but there are already countless guides. Your content better be unique and engaging, or you'll get lost in the crowd.
You clearly didn't understand me. Let's try that again. No, I'm going to use ChatGPT to play Super Mario Brothers. You tell them how to move. Can you beat a level, you think?
Unlikely. ChatGPT can't play games. Your idea is creative but impractical. Look for better gimmicks.
Clearly we have a lot of confidence from ChatGPT. And what do you mean gimmicky? My videos aren't gimmicky. Now you're probably already wondering, who is this odd GPT man that I'm speaking back and forth with? I'm using the API interface for text-to-speech conversion in order to create these voices. So here you'll see we're on the project dashboard. Now, user API keys are being replaced with project-based API keys on OpenAI, so you can create a project like I did here. I'll have some links down in the description for you guys to kind of get to these pages, but Google is the best way. They do change spots and different things. You'll see I created just a test project, and inside of here, that's where I was using that chat interface, and there's API keys below that you can utilize. Now, once you got your API key, if you want to follow along, the GitHub is down in the description, and the only thing you'll have to do is create your .env file and create a variable inside of it called API_key. So I'll show you as an example, .env_test. You obviously don't want to call it _test. You want yours to be just .env. And in here, you can tell from the code I'm grabbing this variable. So you want to say equals and then your API key right here. Now you've probably been hearing that great voice straight from OpenAI that's been talking back and forth with me. That's actually coming from the API interface. That's also going to be how we create moves using that same API interface. So you'll see here, once you have that API key, you can pass that to the OpenAI function and get your client here. Now you're gonna have to install all the libraries that I'm using in this in order to run this project. So I'll have a requirements.txt in that GitHub, and all you'll have to do is open a terminal and do pip install requirements.txt like this. It's pip install -r actually, requirements.txt like this, and this will get you all the libraries that you need. But as you can see, the basic idea of this is OpenAI is going to charge us for these API requests. So when we send them that we want to convert something to speech, we can do something like clarity coders here. And then just based on how I created this, it's going to store that in the speech folder with whatever file name we pass. So let's go ahead and run this, and then we can take a look at how this is actually working. What do we want to call our file? We can call it clarity coders. Hit enter there. And now inside of the speech folder now, we have a clarity coders MP3. Let's take a listen to that.
Clarity coders.
Thank you, good sir. Now I'm going to add another file into the mix here called random agent. It comes with a ROM that you can use here called AirStriker Genesis. And that's what we're going to start out with to see if we can get our AI to play the game, because it's a little bit easier and it's built in, so you don't have to go out anywhere and get it. Now, if you want to follow along with Super Mario, you're going to have to go out and get that ROM legally, of course. Don't sue me, Nintendo. I love you. So let's go ahead and try this. All this is doing is it's going to use retro, and it's going to sample the action space of the game and then make a random action based on that sampling. So let's go ahead and play here, and you'll see it's just playing the game with random action. So that's close, but that's not what we are trying to accomplish here. But you can play around with that file if you wish. So after a bit of playing around, I created this file. It's called GPT test. And what we're going to do is we're going to use images and see if it can give us a valid response on how to play the game. So we're doing it just like we were before. Let's add our API key. We'll get a client. We're going to pick an image path, and you'll notice that's not in here yet. So we'll work with that in just a second. We're going to have to encode that image in base 64. This is just from the doc, so we're actually going to use that to then pass it to our client. Now here is the interesting part. So this is where we do our chat completions and create that chat. So the first one, we're just going to say the role is system. The content we want to pass is what's in this image. Then our user content, we can actually pass them the image. Okay, so this is gonna give just an idea of what types of messages we're going to get back and how we can use it. So let's find an image that we can use for that. And I'm actually gonna put it in this one here. So I have a test striker image, and it just looks like this. Now it's gotta be shrunk up so it can use it. And we're gonna have to adjust the path, right? So it's at /images/test_striker. Let's escape this, / there. Let's try that and see if it runs. It looks like it did. Oh wow, yeah. So it has a lot of detail about that image. So it is able to break down that image for us. You'll see it gives us the lives, the score, high score, the background is black, all that good stuff. Now, one thing that we notice here is it's just passing us back text. So there are some options inside of this model to give it more structured responses. So that's what we're gonna look at next. Can it give us the specific buttons to push? So let's make this a little more detailed here. So below our model, we can add in that line that will help us format this. So now we're saying we want this to be a JSON object that it gives us back, and I'll show you what that looks like. And it will also yell at us if we don't tell GPT what we want the JSON format to look like. So let's replace this line here with our new format. Now you'll see here, we're defining what the JSON format is. So we're saying we want you to have a key called move. Inside of that, we must have a left, right, and shoot, and each value must be true or false. And then a comical explanation of why you're picking that move. And then we're passing it that image. Now we can also tell it why or what it's doing specifically. So we can leave this as the JSON format. And then above that, we can say, pretend you're playing the game, pick your next move. Now remember, it's using this test striker image, so a logical move would be maybe right or shoot, something along those lines. Maybe even left and shoot. Let's go ahead and run this. And what you'll notice here is the response is easier for us to actually process in our program. You'll notice it has the keys that I defined, and it also keeps it in a format that we can then use it in the program. Now, all we have to do is turn this into a way to interact with our program. All right, after a bit of coding, we have a couple new files here for us to try out. Now, I haven't tested this too much. We're gonna kind of go through it here and see what it looks like. But we have a playStriker.py and then a GPT.py. So inside of this playStriker.py, this is gonna be in the GitHub, so you can try her out, but you'll be able to add a prompt here so you can see what I'm kind of defining to the engine to avoid collisions with enemies by moving left and right, shoot the aliens. I also gave just a few details about the game, like asteroids can't be destroyed and the green bullets can't be destroyed. As we talked about, if you're using this JSON format, you have to define what JSON format you want, what you want the format to look like. So we're gonna say that we want a move from them specifying what buttons to press. And the keys in there must include left, right, and shoot with Boolean values. So they're either going to say the left button true for pushing down the left button, or the left button false for not pushing down the left button. Then I also want some thoughts from GPT, so I'm gonna say also include a key for thoughts with a comical explanation of why you're making that move. I also said I love jokes from The Office. I have a little helper function in here. So basically how this game works in Retro, there is an action space. Now an action space defines what your actor can do in an environment. So in this case, our actor is the spaceship itself. Now the action space actually has more buttons than what we want. It's emulating the actual controller. So it has a button for each controller, 12 different buttons. We're only going to use 3 of those buttons, the shoot, left, or right. In order to press those buttons, we just change the value of that button from 0 to 1. So if our dictionary has shoot as true, we're gonna change the 0 index to 1, and that will allow us to shoot. Now the 6 index is left and the 7 index is right. As you can see, I was doing debugging, and I have a very professional method here of debugging. We'll delete that out. All this is just stepping through the game. We can go through more details if you want, but it's pretty simplistic. So essentially every time we loop through the game, we are going to render it so we can see. We're going to get an image and save it. We can also save a previous image. I played around with the idea of that in my head a little bit for passing it 2 images, but we'll start with 1 for right now. And then we're going to use a function that we created to actually pass the message to ChatGPT. And that's in this gpt.py. So all it does is define the model, get the client, things like that we talked about in the last video, and then eventually pass the prompt, the image URL, and the last move to ChatGPT. Another one of my brilliant debugs here. I do know how to debug, I promise. These fun projects, the coding gets sloppy sometimes though. All right, let's go ahead and run this. I think I know an issue that we're gonna have already, but it's easier to explain once you see it. So let's go ahead and run here. And you can see what's happening here. So I maximize this so now you can't see the command prompt, but essentially we're making calls way too often. Look at how slow those stars are moving, and each time we're making a call to ChatGPT, and that's gonna hurt us for a couple reasons, right? First of all, we can't get through the game. This is boring. Second of all, it's gonna hurt our pocketbook a little. Each of these calls to ChatGPT is coming in at around ½ a cent right now. So one thing we can do here is we can, instead of moving every step in the game, because that's probably faster than what even a human can think, we can move once every 10 steps or once every 20 steps in the game. So we're already counting our steps. Let's go ahead. I think we're already counting our steps. So what we can do here, we can take from IM all the way down to our step counter. Let's tab that inside of an if statement here. And all we're gonna do is say if steps mod 20 equals 0, then we wanna make a move. In order to only move once every 5 frames or 20 frames, we're gonna use modular division. If you look at a typical division problem like 6 divided by 3, 3 goes into 6 2 times, so your answer is 2. If you look at another division problem like 7 divided by 3, you get 2 with 3 repeating. We can also display that as 2 remainder 1. When we look at modular division, we're focused on the remainder of the problem. So 6 mod 3 equals 0 because there's no remainder in that first problem. 7 mod 3, you have the remainder of 1 like we seen in the second problem. You see this in programming a lot because it allows you in one line to define something to happen every so many steps or frames or whatever it is. So in our program here, we're going to say if our steps or the frames of the game is evenly divisible by 5 or mod 5, then we're going to do our action and perform in the game. So this is going to run every multiple of 5. So it's going to run on step 5, step 10, step 15, step 20, so on and so forth. So let's just take a look and see what that looks like. And you can see that's looking a little bit better. So it looks like we're getting a few movements, but we also are starting way early. And you can see we shot there. That was good. I don't think I made sense what I said there. So you can see that we're the menu is still up for a long time. The intro of the game is still up for a long time. So we want to avoid that as well. So we're going to say if it's divisible by 20 and the steps are greater than 190. So essentially, actually, let's just say 200. So essentially, we won't move for the first 200 steps. And then after that, we'll only move once every 20 steps. Let's go ahead and give this a try. It's looking pretty good. Oh, we died. That's not great. I didn't actually see what happened. See, now we're on life 2. Now we got an enemy. He shoots. That's good. There's a green bullet, so we should move to the right, hopefully. But he does, and to the left. Now we're only moving once every 20, so the moves are pretty erratic. That's fair. That would be tough. So what we can do here, let's shrink that up just a little bit and just see if we can get any farther in the game. Let's say we're gonna move every 10 steps instead. Kind of the happy medium there. Hey, look, I can actually make it bigger.
That's what she said.
Move to the right, that makes sense. And we died, I'm not sure what happened there. Let's see what happened. Well, as you can see, well, it looks like I'm as good at dodging as Michael Scott is at managing. Let's give it another shot so it knows it died. All right, one more time. Let's go 5 steps. See what we can get. 10's still a lot for this game, I'm sure. One right there. Hopefully we'll move to shoot. Now we need to move to the left. There you go. Or right, I guess. That's good. Move back to the right. I don't love that. Back to the left. That's good. And back to the right. Let's see what it said before it moved right. So it sees that there's a threat in sight, but it wants to veer to the right to avoid and shoot the aliens, but there's clearly a projectile to the right of it. So we've come a long ways. We got something that's functioning here, but we need to work a little bit and figure out our prompting and different things like that. So now that we have something functioning, let's go ahead and try to jump into Super Mario Brothers. I've added another file here called mainmario.py. It's basically the same thing, but it's set up for Mario. So we're going to give some very basic prompts right here, and then depending on how it does, we can kind of try and manipulate it here. Maybe it'll win with just these prompts. So I'm just gonna say avoid collisions and reach safely at the end. Try your best using knowledge of Super Mario Brothers for SNES. Now, as we talked about, we're gonna have basically the same stuff here. I don't think I use thoughts anymore. Oh no, I don't use the move one. So let's remove this message one. Want to try something different though. Let's just say, boom, that. See if this works. And then I'm also letting them choose how many frames you want to skip. So we can start at 20, but they can skip more values if they think it's appropriate. So this is how fast their next decision will come. Let's go ahead and try this, just see what it runs like. Gotta expand it here. So I'll speed this up a little bit, but the API calls obviously take time to come back. That's where you're seeing this delay as it goes through. And I'll read some comments along the way. And then at the end, I'll do a summarization. So I'll do about 10 runs. I'll tell you how many win, how many lost, and what the average cost is per run. And we'll also show the best run. Oh man, that pop-up threw it off so much it killed the program. Now that we got this dialed in, I'm gonna play around with some different prompts and we'll come back with the winning one.
Time to leap over that Koopa shell like a graceful gazelle. Whoosh! Let's hop to it and grab that coin while avoiding those Koopa Troopas. Mushroom blocks are there, but dodging Koopas is my top priority. Let's keep running to the right. Time to show those Koopa Troopas who's boss. Let's keep moving, right? I'm no cloud watcher. Running might get us to the steps faster. Let's zoom towards the goal. Time to leap over that football guy. I'm not drafted for your game, buddy. Looks like a good time to leap forward and grab that checkpoint. To infinity and beyond. Let's make a grand jump to that platform. Let's go up, up, and away. Mario is a professional jumper after all. Alright, let's reset that jump and get ready to traverse this gap. Time to leap forward to get past these pipes. Don't want to get stuck here. Running forward with confidence, Mario. Those pipes won't know what hit them. But wait, keep an eye out for any nasty surprises popping out of those pipes. I can see the finish line. Time to sprint like a plumber late for his pasta dinner.
Thanks for watching, guys and gals. Let me know in the comments if you like this sort of video, and I'll pump out some more. Please subscribe if you haven't. Those subscriptions allow me to dedicate more time to the channel and create more videos. Now, while we're looking at the monthly spend here, you can see that I did spend a little money on this video just for the testing side of things. So around $37.46. I had one run, this last one that I just did for kind of this wrap up video here, that was about 14 cents. So in total to test this video, we're talking like a little under $40. In general, to run one game of Mario, it was around 14 cents with the current prompts we're using and different things like that. In terms of success, we hit about 1 out of every 10 were a win when we were testing it. Again, if you like this video, let me know. And until next time, keep coding.